Alright guys, this is the chemistry and honors chemistry video on Unit 11, Section 1. That's Chapter 14, Section 1. It starts on page 476 in your books. If you haven't read that or went over the vocab, stop. Don't watch this video. Hit pause, go do that, come back to me. Pay special attention to the figures and the charts, or the table at least, on the top of page 477 and 479. And come back to me. Alright, now that's taken care of. I'm going to be lecturing off of the Google Slides notes that I usually lecture off of. They're going to be available to you through Classroom. I advise you open both the video and this slides and look through both of them together. Alright? So, heterogeneous mixtures. We talked about these way back in like August, September, but we're going to dive a little deeper than we did back then. Okay, we did talk about this also back in 9th grade if you had me for physical science. So suspensions versus colloids versus solutions. Okay, so suspensions have particles that are large enough to settle out, and they can be separated via filtration. There's a type of mixture called a thixotropic mixture that works as a liquid when it's stirred, but once that kinetic energy dissipates and it stops moving, it actually works as a solid. It's some really cool stuff, and you can see it modeled, I believe, in the figure 1. Colloids, the particle size is a little smaller, and so it is no longer able to be filtered unless you have some really, really nice filters. If you've got some really nice filters, you can filter these, but those are expensive, and you're probably only going to find those in pharmaceutical grade stuff. Alright, so there are a couple of different things you need to know with colloids. The dispersion medium is whichever part of the colloid has more particles. That's it. Just whichever one has more particles. The dispersed particles are the substance, forgot the word, that has less of it. Alright, so if you wanted to figure this out, you could, I guess, count them, but that would take forever. You could use moles, right? So the one with lower amount of moles would be the dispersed. The one with more moles is the dispersion medium. Right? A way to actually interfere with colloids is to add an electrolyte, because the electrostatic layering that occurs inside colloids to keep them from settling can be not switched off, but lowered. That intermolecular force, the dipole-dipole forces, can be lowered so that it can settle. So that's a way to separate them, is by adding an electrolyte. All right. With colloids, you can also actually observe Brownian motion, which is just that erratic particle movement from the collision of particles. We talked about this when we first started talking about intramolecular forces as well. Those dispersion forces. Scale them up and you get Brownian motion. All right. The Tyndall effect is where you take a flashlight and shine it through either the solution, the colloid, or the suspension, and depending on what you see in the beam of light tells you what it is. All right. So the figure on the top of page 478 shows you a colloid scattering light, while a solution doesn't. In my slides, I show the solution, which has no light beam visible, versus the colloid, which does have a light beam visible, versus a suspension, which not only does it have the light beam visible, but you can see individual particles. So this is a good way to test. If we were in class, I would have an example of this. I'm sorry, I'm going to post a video that has something so you can see it. All right. And then just some vocab real quick. Soluble versus insoluble. Soluble means that it can form a solution. Insoluble means it cannot form a solution. Miscible versus immiscible means it can't be mixed. All right, so oil and water are immiscible. Right? Water and vinegar, miscible. Right? Salt water is a solution, right? But if you throw a bunch of rocks in some water, they're going to be insoluble. They're Thank you.